Hi to you watching this video. So for this video, we're going to discuss about module number 6, Tacheometry. So this module will explain and illustrate the methods and uses of tacheometry. Stadia leveling, stadia interval factor, measurement by stadia for horizontal distance, vertical distance, and inclined distance. Okay, so tacheometry. So tacheometry is defined as a procedure of obtaining horizontal distances and differences in elevation based on the optical geometry of the instrument employed. Okay, so it is defined as the procedure of obtaining horizontal distances and differences in elevation using only the geometry of the instrument employed. Okay. So, tachyometric surveying. Tachymetry or telemetry is a branch of angular surveying in which the horizontal and vertical distances of points are obtained by optical means as opposed to the ordinary slower process of measurements by tape or by chain. So, this method is very rapid and very convenient. Okay? Nabilis lang siya and convenient because we only need the geometric device, the surveying device, and the Istaja rod. Okay, so it is best adopted in obstacles such as steep and broken ground, deep ravines, stretches of water or swamp, and so on, which make chaining difficult or impossible. So, pag hindi kayang mag-chaining or mag-tape, this method is quite uh, useful. Okay, so the primary object of tacheometry is the preparation of contoured maps or plans requiring both the horizontal as well as the vertical control. Also, on surveys of higher accuracy, it provides a check on distances measured with tape. So tacheometry, from the Greek word which means quick measure, is a system of rapid surveying by which the position, both horizontal and vertical, of points on the Earth's surface relatively to one another are determined without using a chain or tape or a separate leveling instrument. Okay, so what is Stadia method? So the equipment for Stadia measurement consists of a telescope with two horizontal hairs called the Stadia hair and a graduated rod called the Stadia rod. Okay? The Stadia method is especially well adapted to mapping requirements and is widely used for locating the details and contour points in topographic surveys. It is far more rapid than taping, and under chain control, certain control conditions could be made as precise. This method also requires the employment of fewer survey personnel. Okay. So the principle of Stadia. Stadia method is based on the principle that in similar triangles, corresponding sides are proportional. Okay. So standard symbols used in Stadia measurement. So this is your telescope. This is your Stadia rod. Okay. So we have here the F. F is the focal length of the lens. So I hope you can still remember your physics where you were able to discuss about focal length of a lens. Okay, so that is the focal length. Then F1 is the of image distance or length from the center of the object lens to the plane of the cross wires when the telescope is focused on some definite points. While F2, while F2 is the object distance or length from the center of the object lens to a definite point when telescope is focused on that point. Okay? So I, we have the distance or the spacing between stadia airs. Okay? So I is the spacing between the stadia hairs. Next, we have here C distance from the center of the instrument to the center of the object lens. So this is the center of the object lens, and this is the center of the telescope, and that is C, small c. Okay. Stadia constant, or this is capital C. So this is your Stadia constant. So Stadia constant, or distance from the center of the instrument to the principal focus. Center of the instrument to the principal focus. Okay, so this is your focus. Or it is simply small c plus f, small f. Okay. This D stands for distance from the focal point in front of the telescope to the face of the rod. So from the focal point to the face of the face of the rod, it is where you're going to have your readings. Okay, so that is a small d. D, capital D, is the distance of the instrument center to the face of the rod. So from the center of the telescope to the face of the rod. So that is distance D. K is the Stadia interval factor. K is equivalent to F over I, focal length over distance or spacing between stadia hairs. And S is the stadia intercept. The difference between the upper stadia hair reading and the lower stadia hair reading. So upper stadia hair reading and lower stadia hair reading. Okay? Yung I, it is the distance or spacing between stadia hairs. So, if nandito yung stadia hair, nandito yung stadia hair, it is the reading between them. Okay? While stadia intercept, it is the difference between the upper crosshair reading and the lower crosshair reading. Okay? So, F over I is equivalent to D over S. So, if you're going to cross multiply, D therefore, or the distance from the focal point of the telescope to the face of the rod, is equivalent to F times S over I. Okay? So, D is equivalent to small d over F plus C. Okay? If you're going to check here, D is equivalent to small d plus F plus F plus C. Okay? So, if but from here, from our first equation, small d is equivalent to F times S over I. Substitute the variables of d. So that would become F over I times S plus C. Okay, but F over I is the Stadia interval factor. So K is equivalent to F over I. Substitute it here, F over I. We have distance D, or the capital D, from the center of the telescope to the face of the stadia. Center of the telescope to the face of the stadia. It is simply equivalent to the Stadia interval factor. The Stadia interval factor times the Stadia intercept plus the, ano yung C natin? It is the distance, Stadia constant rather. Okay? Stadia constant, or the distance from the center of the instrument to the principal focus. So for this one, capital C is being given by the manufacturer. Okay? Manufacturer given yan. Okay. So, the equation D is equivalent to Ks plus C is employed in computing horizontal distances from stadia intervals when sights are horizontal. Okay? I repeat, using this formula is only employed when it is a sight, when the sight is horizontal. So, stadia interval factor. So, the ratio F over I is called the stadia interval factor and is designated by the letter K. For any given instrument, this value remains constant and depends only on the spacing between the stadia hairs. Okay? So, if you have only one instrument, then your stadia interval factor is constant. Okay? The manufacturer of the instrument can space the stadia hairs with relation to the focal length so as to obtain any convenient value of k desired. And the most common value of k, however, is 100. I repeat, the most common value of k is 100. Okay? So determination of Stadia constant for an instrument with an external focusing telescope. The stadia constant is readily determined by setting up the instrument focusing at any distant point at least 300. No, no, wait, napagbaliktad ko. It is the C, it is the K that is oftenly given, which is K, no? Which is 100. And yung C natin is computed. Pero hindi naman ano yan, mahirap i-compute. Okay? So, napagbaliktad. Anyways, let's continue. The stadia constancy is readily determined by setting up the instrument, focusing at any distant point at least 300 meters away, and measuring precisely the distance between the reticule and the objective lens. This measured quantity is the focal length f. The telescope is next pointed and focused on another object about 80 meters away, and the distance from the object lens to the center of the instrument is measured. The distance is called c, and the stadia constant c is equal to the sum of these two measured quantities. The stadia constant represents the distance from the center of the instrument to the principal focus. The most instrument in recent design have internal focusing telescope, and such telescopes, the stadia constant is nearly zero and can be disregarded under all condition. Okay? So, napagpalit natin. But for some instrument, like what is stated here, for some, if it is an internal focusing lens, it is all nearly zero and it is negligible. Okay. Next, determination of stadia interval factor. Now, to determine your stadia interval factor, the stadia interval factor K of surveying instrument is usually 100. Should there be needed, however, to determine the stadia interval factor, a straight line about 100 to 120 meter long is laid off on the ground. Take note, it is laid off on the ground. The selected site should preferably be nearly as level as practicable. The instrument is set up on one end of the line. For an external focusing telescope, a point A is located on the line at distance C, okay, or the stagia constant from the center of and in front of the instrument. However, if the instrument is internally focusing, then the position A is set directly under the center of the instrument. Points are next set on the line using stakes at individual intervals of about 15 to 20 meter. Then the distances D1, D2, D3, and so on are measured from point A to point at from point A to the successive points in their order of placement. The stagia rod is then held on each of the stakes and the stagia interval is read. The stagia interval factor K is computed for each site by dividing the distance from the principal focus to the stake by the corresponding observed stagia intercept. The mean of the successive values of K this determined is taken as the stagia interval factor of the instrument. It is to be expected that the value of k for the several distance will not agree exactly owing to errors in observation and errors from natural resources. Okay? So, inclined stagia sites. So for inclined stagiocytes, isn't it that we said that the formula D is equivalent to Ks plus C is employed in computing horizontal distances from stagia intervals when sites are horizontal. So what if it is already an inclined? Okay, so it is already inclined. So you have here your slope, you have here your vertical inclination angle. Pag pataas, what we call that the angle of elevation or inclination angle. Pag nasa baba taas ka, you're going to view it downwards. We call it the angle of depression. Okay, so if it is already inclined, then the phrases here will give us the the equations that we need to use in order to solve for the inclined distance, horizontal distance, and the vertical distance. Now, to summarize that, for inclined distance or S, or it is the hypotenuse of the triangle, so this is the S. So for the S, it is Ks cosine angle of inclination or depression. If it is upwards, again, inclination. If it is downwards, it is depression, plus C, where K is the stadia interval factor, or F over I, and S is stadia interval, and the angle here, alpha, is the observed vertical angle of elevation or depression, plus C, where C is the stadia constant. Now, for the horizontal, it is Ks cosine alpha squared plus C cosine alpha. And for the vertical, it is Ks cosine alpha sine alpha plus C sine alpha. Okay? So, the difference in elevation can also be solved using the equation height of the instrument plus vertical minus the rod reading. Okay? I repeat, the difference in elevation can be solved using height of the instrument plus the vertical distance minus the rod reading. Okay, so we now try this example. Okay, so we have here the figure. The difference in elevation between observed points A and B is 15 meters, and the horizontal distance between them is 35 meters. With transit station at O, additional information was obtained as shown in the table. So determine the stagia intervals for A and B. Okay, so assume that K is equivalent to 100 and C is equivalent to 0. Okay, so first we need to i-plot natin. We need to plot this, the given. So, the difference in elevation between points A and point B is 15 meters. So, this is your point A and this is your point B. So, the difference in elevation is 15 meters. Okay, so that is 15 meters. And the horizontal distance between them is 35 meters. Okay. So we are to solve for the intervals SA and SB. Okay, so what are the equation for this problem, or what are the working equations that we can use? Isn't it that from the inclined we were given the equation Ks, we have here the H, or the horizontal, is equivalent to Ks cosine theta squared plus C. And for the vertical, we have here Ks cosine theta sine theta plus C sine theta. Okay? But if we are to use the trigonometric identities, masisimplify natin itong V. V can be equal to 1/2 Ks sine 2 theta. So, this will be our working equation in order to solve for the unknown. So we have two unknowns, so we should have at least two working equation. Okay, so let's start with the horizontal. So let's say this is um, this is the horizontal distance b. So this is horizontal distance b, and this is the horizontal distance a. Okay, so yan. Then we have here the rod reading. So for the rod reading at A, so where is A? So this is A. So for the rod reading at A, yan. Okay, so that is our rod reading A. That is equivalent to 1.863 meters. Then the rod reading at B, RRB is equivalent to 1.5 meters. Okay, and the angle that it makes with the horizontal for A, for B is 10 degrees, while for A it is 12 degrees. Okay, let's now use that for our equation. So HA is equivalent to KS cosine theta squared plus C. But take note, C is constant. Okay? So, we have here, our C here is 0. So, dito, pagka-cancel out din naman si C. Okay? So, yeah. Then, what is our K for A? K for A, that is a 100. The Stagio interval would, the Stagio interval factor is 100. So, we have 100 times SA, because that is unknown, SA. So, that is SA, that is SB. Okay? So, SA cosine theta, what is our theta for A? It is equivalent to 12. Okay? And that is equivalent to 100 cosine 12. So that is equivalent to 95.677 SA. Okay, now for HB. So for HB, that is equivalent to KSB cosine theta squared plus C. K is equivalent to 100 times SB cosine 10 degrees squared plus C. And C will simply cancel out. Okay? So, substituting the calculating the value, we have, palitan lang natin si 12 ng 10. So, we have 96.985 SB. So, this is my equation 1. This is my equation number 2. But that is not enough. Okay? Because we do not know HA, we do not know HB, we can still solve for SA and SB. Now, we look into our equation for the vertical. So, for our equation for the vertical, we have VA. Okay? So, VA is equivalent to 1/2 K SA sine 2 theta of A. So, that is equivalent to 1/2 times 100 SA sine 2 of what is the angle for A, that is equivalent to 12. And VA is equivalent to 0.5 times 100 times sine 2 times 12. And that is equivalent to 20.337 SA. Okay? Now for VB, for the vertical B. VB is equivalent to, we have 1/2. So 1/2 KSB sine 2 theta B. So substituting the value, we have 1/2 times 100. What is SB? SB is equivalent to unknown. So sine 2 of 10 degrees. Okay? So, palitan lang natin si 12 ng 10. VB is equivalent to 12.101 SB. But still, it is a problem because how are we going to equate these two equation? Okay? Kasi yung equate natin si SB, unknown si HB, unknown si VB. Likewise with SA, unknown si HA, unknown si VB. So we need to find the relationship. Okay? We need to find a relationship wherein we can equate these variables. So if we're going to check, HA minus HB is equivalent to 35. Okay? So HA minus HB is equivalent to 35, and that is from the figure. Okay? So if we are to substitute the value of HA, we have 95.677 SA minus 96.985 SB is equivalent to 35. And let's say this is equation 3, this is equation 4, this is my equation number 5. Okay? So that would be my equation number 5. Now, I need to have another relationship. Okay? Because we still cannot solve them. Okay? So we need to find another relationship. So if we're going back to our figure, the difference between point A and point B, so that is point A and point B is 15. Okay? But take note, the vertical reading, VA, the vertical reading VA is between the horizontal line of sight, which is this. So if we're going to extend this, okay, so this is our VA from the rod reading at A. So this is the rod reading at A. So this is our VA. And for the VB, it is the horizontal line from the horizontal line of sight, which is this, no? And yan. So this is VB. So mas mababa siya ng konti. From the elevation at B. Okay? So yung VA will include the rod reading, yung VB will include the rod reading at B. Okay? So ang mangyayari, we have VAA. So we have VA. So VA minus. So VA minus yung rod reading now at A, which is 1. Kita ba? Which is 1.863 minus RRB or VB minus VB minus yung rod reading ng B, which is 1.5 is equivalent to 15. Okay? So, simplifying this, I am going to substitute equation 3 and equation 4 into equation number 6. So, substitute 3 and 4 in equation number 6. So, we have VA is equivalent to 20.337 SA minus 1.863. Then we have minus VB. We have VB here, and VB is 17.101 SB plus, i-distribute natin yung negative, we have 1.5, and that is equivalent to 15. Okay? So, simplifying it further, let's combine similar terms. So, we have here 20.337 SA minus 17.101 SB is equivalent to, we have 15 plus 1.863 minus 1.5. So that is equivalent to 15.363. So transpose this to the other side of the equation to make it positive. So SA, then divide both sides by 20. So isa-isahin natin. We have SA times 20.337 is equivalent to, we have 15 plus 17.101 SB. So divide both sides by 20.337. Divide both sides by 20.337. Okay? So that will simply cancel out. So SA is equivalent to, we have 15 plus 17.101. No. This will now be our equation number 7. So we have 15 plus 17.101 SB over 20.337. This is now my equation number 7. So what I'm going to do is substitute. So substitute 7 in equation number 5. Okay? So this is equation number 5. That is in terms of SA. So we have here 95.667 times SA, and SA is equivalent to 15 plus 17.101 SB over 20.337 minus 96.985. SB is equivalent to 35. And we compute for the value of SB. So 15 plus 17.101 alpha x over 20.337 minus 96.985 alpha x is equivalent to 35. Okay, so SB is equivalent to 2.15. Okay, then substitute this 215 to your equation number 7. You can get your SA. SA is equivalent to 2.15. 15 plus 17.101 times 2.15 divided by 20.337, and that is equivalent to 202.55, and that would be the value of SA and SB. Okay? Wait lang, may mali tayo. Hindi natin na-include yung decimal. So this is 15.363. This is 15.363. This is 15.363. So mali, nagkamali. So we have here 95.667 times 15.363 plus 17.101 alpha x over 20.337 minus 96.985 alpha x, 96.985 is equivalent to 35. And we have here 253 rather. SB is equivalent to buray natin. SB is equivalent to 2.253 meters, and SA is equivalent to 2253 divided by 20.337, and that is equivalent to 0.65 meters. Okay, so be very careful when writing your values, kasi katulad yan, nagkamali tayo dyan. Okay? Okay, so we have here Stadja leveling. So Stadja leveling operations are similar to those of differential leveling, except that in Stadja leveling, the line of sight may be inclined. Okay? may be inclined from the horizontal. This rapid method of indirect leveling is well suited in rolling or hill country where a relatively low order of accuracy is accepted. So sample problem, we have here, complete the Stadler level notes shown and perform arithmetic check. Assume that k is equivalent to 100 and c is equivalent to 0. Now for the difference in elevation, we're going to use this equation. dE is equivalent to rod reading of the backside plus or minus the vertical distance of the backside plus or minus the vertical uh, reading of the foresight minus the rod reading of the foresight. Okay, so we have here our BM1. So for BM1, there is no foresight because this is our first, this is the first setup. So we only have here the backside reading. Okay? And for the foresight, ito naman yung foresight reading natin. This is TP1. So this is the foresight. Then nung lumipat na tayo ng station or we transferred our instrument here, we are going to backsight our TP1. So this is our TP1 and nung nag-foresight tayo, ito na yung ating foresight. Okay? So these are the foresight reading. So the first thing that we need to do is to determine VD. Okay? So VD here is equivalent to, again, yung ginamit nating equation kanina. We have it here. So V is equivalent to, so VD is equivalent to Ks cosine theta sine theta plus C sine theta. Or we have here VD is equivalent to 1/2 Ks sine 2 theta. Okay, let's try to use these two equation. So, dapat magbibigay yan ng parehas na answer. It should generate us the same answer. So, let's try both equation. So, solution, we have the first one. So, VD is equivalent to, what is K? It is 100. So, that is 100 times the S. What is the S? 1.245. 1.245 cosine. I-remove na natin yung angle because the angle is just saying that it is downwards. And if it is positive, it is upwards. Okay? Downwards, it is an angle of depression. Upward, it is angle of elevation. Okay? So, yeah. So, we have here 4 degrees 25 minutes times sine 4 degrees 25 minutes. And C will cancel, C sine theta will cancel out because C is equivalent to 0. Okay, so we have here 100 times 1.245 cosine 425 sine 425. And that is equivalent to 9.559 meters, and that is meters yung units natin. Okay, let's try the second equation. VD is equivalent to 1/2 times 100 times 1.245 times sine of 2 times 4 degrees 25 minutes. So we have 0.5 times 100 times 1.245 times sine of 2 times 425. And that is equivalent to 9.559 meter. And they have the same answer. Okay? So, whichever is convenient for you. So, dito, lagay na natin, we have 9.559. Now, for the TP1, let's solve first for the VD para mas madali na yung ano natin. Pag-solve yung difference in elevation and the elevation itself. Okay? So, next VD of, this is BM1. BM1. Then, we have VD of TP1 backside. So, that is equivalent to 1/2 times 100 times 2.044 times sine 2 of 3 degrees 20 minutes. And that is equivalent to 0.5 times 100 times 2.044 times sine 2 of 3 degrees. Mali. So that is 3 degrees 20 minutes. And that is equivalent to 11.865. And that is in meters. So that is 11.865. Okay. Next would be ito, VD. So VD of TP1 foresight. So that is 1/2 times 100 times the S, which is 1.515 sine 2 of the angle is 8 degrees 18 minutes. And that is equivalent to 0.5 times 100 times 1.515 sine 2 times 8 degrees 18 minutes. And that is equivalent to 21.6641 meters. And lastly, we have the VD for BM2, and that is foresight. Okay. We have 1/2 times 100 times the S, which is 1.438 sine 2 of the angle 3 degrees 25 minutes. That is 0.5 times 100 times 1.438 sine 3 degrees 25 minutes. So that is 4.285 meters. Okay. So sulat natin. The VD here is equivalent to 21.641, and this is 4.285 meters. Okay. Now we need to determine the elevation or the difference in elevation. So DE, we have DE of TP1. Okay? Parang yung procedure natin dati, pag ganon. Okay? Kung maalala nyo yung sa differential leveling natin. From the elevation, backside, foresight, then you can get your elevation. Okay, so let's follow the equation. So according to the equation, it is rod reading of the backside. So what is the rod reading of the backside? So that is 2.42. Dito, it is plus or minus. If the angle of your foresight is positive, we are going to use plus sign here. Okay? So since it is plus 8 degrees, so magiging plus, what is the VD of the backside? That is 9.559. Then, again, that is positive. So, plus ang gagamitin natin. Plus, what is the VD of the foresight? The VD of the foresight is equivalent to 21.641 minus the rod reading of the foresight, which is 1.55. Therefore, the difference in elevation for TP1 is equivalent to 2.42 plus 9.559 plus 21.641 minus 1.55. And that is equivalent to 32.07. And that is in meters. Okay. Now, to get the elevation of your TP1, our reference here is BM1. So, the elevation in BM1 is equivalent to 75. Ngayon, positive yan. So, we are going to add. Kahit mag-negative yan, ipag-add natin because positive plus negative will give us a difference. Okay? So, if we are to check it graphically by observation, mas mataas yung elevation ni TP1 kesa sa elevation ni 75. Therefore, alam natin na ipag-add yan. So, we're going to add. So, 75 plus 32 is equivalent to 107.07. Next is the difference in elevation for BM2. So DE of BM2. So follow natin equation. Rod reading of the backside, rod reading of the backside. We have 202.044. Then, is it plus or minus? Take note that the angle of the foresight is negative. Therefore, we're going to use minus. So, minus, um, wait, wait. Mali. This is rod reading of the backside. It is 1.08. So, DE is of BM2 is equivalent to 1.08 rod reading of the backside minus 11.865 plus or minus. It is minus again kasi negative siya. So, minus the VD of the foresight. So, VD of the foresight is 4.285 minus the rod reading of the foresight, which is 3.06. So, yun, minus. So, DE of BM2 is equivalent to 1.08 minus 11.865 minus 4.285 minus 3.06. And that is equivalent to, wait. May mali tayo. Mali natin ito. Let's double check this one. So, VD is equivalent to 1/2, 100 times the S of the foresight. That is equivalent to 1.438 sine. So, baka mali yung calculation natin. 0.5 times 100 times 1.438 sine 2 3 times 3 degrees in 25 minutes. So, it is not 4. Rather, it is, mali ito. Mali yung calculate na input natin sa calculate. It is 8.555. So, this is 8.555. So, this is 8.555. Okay? So, 1.08 minus 11.865 minus 8.555 minus 3.06. And that is equivalent to negative 22.4 meters. So, we have here negative 22.4. Okay? So, we just simply add them. So, we have here 1.07 plus negative 22.4. And that is equivalent to 84.67. So, if we're going to check, tama, because the elevation of the TP is higher than the elevation of the BM2. So, mas mababa yung elevation ni BM2. So, that's how you solve for the difference in elevation.